Welcome to my solution to the chaining Hashmap practice quiz. And so today I'm going to have to put together or implement the put method that puts or makes an association between this key and the value in a Hashmap. So here's my browser or my text editor. Hashmap that uses chaining. Author, more, public class, Hashmap chaining. This isn't very well named. We shouldn't tell the user how we implement it. It's not for them to worry about how we implement our class, but for clarity, I'm going to call it chaining. It has a private linked list entry. Okay, so we have a linked list of entries and we have an array of the linked lists table. So the array holds the linked lists, and then we are implementing the associates the value with the given key. So we have at param key at param value, the value, and we return the previous value associated with the key. Public, we return the old value, put, we take a key value. I can't type today. Okay, and we have our private class K and V. Private key, private type V value. Okay, so again, we need to create an index or a hash code, a hash for this key to find out where in the array we start our linked list. Well, which linked list should this value or this entry be? So let's first off create the entry equals new entry K and V, and so entry dot key equals key, entry dot value equals value. So we can now store this entry in the correct linked list. So now we want to find out int, and I'm going to call it hash is equal to key dot hash code. So that gives me an integer. I need to mod it by table dot length, but that's a negative that potentially is a negative number, so I'll add table dot length. No, that won't work. So if hash is less than 0, I want to say hash plus equals table dot length. Okay, so now I have the thing, so the linked list entry K V list equals table dot hash. So now I've got the linked list. I need to see if the item, that entry, is in the linked list, so I can say int index equals list.index of entry. So that will find me, that won't work, sorry. That won't work. So for int I equals 0, I is less than list.size, I plus plus. Oh, let's do it the smart way. For entry K V E list. Okay, so now we're going to loop over all the things. So if E dot key dot equals key. So we found the value. We say v old equals e dot value. Remember the old value. We want to say e dot value equals the thing that we passed in, value. So we replace the old association with the new association, and then we return the old association. So we found the key in the linked list by searching through the linked list. We found the key, we then we store the old value because we need to return it. We replace the old value with the new value, and then we return old. So we get to the end of the for loop. The key was not in the table or in the list, so we say list.add entry. And what do we return? There was no value associated with the key, so we want to return null to indicate that we just added this new one in, and the old association value was null, so there was nothing there. So in this case, because we're using chaining, we calculate our hash or our index, we get that linked list, we search through the list looking for the key. If the key is in that list, we then remember the old value, replace the value, return the old value. If we get to the end of the linked list and we haven't found the key, then we have to add the entry to the linked list, and we return null, indicating that there was no value associated with this key in the hash map. Thank you very much for your attention.